Welcoming Gareth Western.
Hello, thank you. Yes, that intro was written by ChatGPT as well. So I see the emojis that I had in the slide haven't really come across. That should have been some mer people, so merman and mer lady. So when you see those, just substitute those with emojis. Hi, my name is Gareth Western. I'm a consultant at Bouvet, working now as a solutions architect for Team Horizon at Statnet. And we are building a cloud-based data platform in Azure. This talk in one slide, it's sort of the triangle that Beate was showing in her keynote between digital infrastructure, data, and software. So where Horizon, we're putting together the digital infrastructure for the data platform, focusing primarily on Delta Lake for the storage component of the data. And Apache Spark is one of the processing options for compute, the software that you can use. There are other alternatives available, but I'm going to talk a little bit about that today. So first, Horizon. What is Horizon? It's a part of the Statnet Data Platform group. This is a constellation of different teams, but Horizon is the one in the middle there, analysis and lagerings platform, data saving platform. But we work closely with the other teams, Catalogtjeneste, Rapportering, to build the complete data platform picture. We are also an enabler of data mesh. What does that mean? The four key principles, really. Building a self-service data platform for the domain-oriented data teams to build data products which adhere to the principles and guidelines of a federated approach to data governance. So by federated, we mean we don't want to become a centralized data platform where we have to do a lot of the work for the teams, but we want to enable the teams to be sort of self-sufficient in their work, but within sort of the guidelines of the information verwalting and everything, the guidelines that Statnet sets out. From a technical perspective, Horizon is a collection of tools and technologies that you see here. We're going to start today with the HDL, the Horizon Data Lake, or Delta Lake. I'll talk a little bit about that first. But before we go into details, we need a bit of a history lesson. Going back to a few decades ago, for business analytics, there were data warehouses where all structured data would come in through a sort of an ETL process, extract, transform, and load into a data warehouse, and then all the business insight, BAE and reporting use cases would go from that data warehouse. And this worked for a long time. There's lots of literature and best practices around this. But then, as storage and compute became cheaper and cloud became a thing, people started creating data lakes in which they would start pumping all sorts of data, structured, unstructured, semi-structured. And yeah, there would still be the ETL processes taking the data from the data lake, perhaps pumping it back into the lake in different areas, or onwards to a data warehouse for yeah, the BI and reporting use case was still there. And data science and machine learning also became new use cases. They came up with new uses for data from both the data warehouse and the data lake. And this was working well enough, but it became suddenly a bit more complex to have this sort of two-tier architecture between the data lake and the data warehouse. And so in more recent years, this is, we've seen a trend towards what's now called the data lakehouse, where the distinction between the data warehouse and the data lake is a bit more blurred. People can do more directly from the so-called data lakehouse with the addition of this metadata and governance layer in the lake area. So I'll talk a little bit about how that's achieved. First, also a common pattern that's used in these lake houses is the so-called medallion architecture, where data will traditionally go through a series of layers. Doesn't really matter what you call them, but traditionally people say bronze, silver, and gold. The most important thing here is that these denote the quality of the data stored in the lake house at the different layers. So bronze and raw is when the data coming in, so raw data. Silver, processed, is where it's been transformed into maybe information. And then taken to the next level, gold is the semantic model where the information becomes knowledge that's used for the concrete use cases. In HDL, we provide the bronze and, raw and processed, as we call them. And it's the Rapporterings team with Power BI that's providing the semantic models. But we do see there's a trend where those lines are becoming more and more blurred as well. The semantic model is sort of part of the lake house architecture as well. So that's something to watch for future. You may have noticed back in this picture that on the process layer there's a little logo there, a Delta logo. So let me talk a little bit about Delta Lake. Delta Lake is an open table format, similar to Apache Hudi and Apache Iceberg. It's created by the founders of Databricks. And it provides a layer of abstraction on top of the data lake. That's the metadata and where the control comes in, which I'll talk a little bit more about. But it provides a range of benefits for working with the data, so that it's a lot easier to perform analytical queries directly on the lake without having to worry so much about the performance problems of a traditional data lake model. Also, I realized Delta Ponoshk is to participate, which I think fits nicely with the theme of community. So, sorry. There is a thriving community around Delta Lake. 40,000 LinkedIn followers, loads of LinkedIn views and blog views, 80 million downloads a month as of March. That was recently updated to 20 million in April. So it's growing and popular, and there are definitely users. We also see from the interoperability map that Delta has support from a wide range of vendors and projects and languages. Although the kernel is written in Rust, there's Python bindings for that, and several other Python projects building on top of those as well, or building their own implementations. Other languages are available as well. Since I mentioned Delta Lake was founded by Databricks, Databricks is also the provider of the creators of Spark. And so the JVM ecosystem around Spark and the distributed processing frameworks is quite large and growing as well. New vendors are continually adding support for Delta as well. Google recently announced that Delta is now supported in BigQuery as well. And Microsoft Fabric, in the Microsoft ecosystem, they have Delta as the underlying support system, underlying storage format in OneLake. And as I said, new vendors are adding support all the time. It's fast, one of the reasons we chose it. So here's graphs, sales, pitches, but here's a quick breakdown. If you had a raw text file in CSV, you can see that, simply by converting to Parquet, a binary format, you would get an instant speed up in your analytical queries. Parquet is a columnar binary format, so there's a lot of improvements over the raw text base. Parquet also has a lot of useful features in the specification for improving performance even further. So something called filters. If you can specify more precisely which data you want to read, for example, which columns or which values you want to read in your Parquet files, you can improve performance significantly there. And again, by converting your Parquet files to a Delta table, you can get a great performance boost out of the box as well by adding that metadata. So Delta will provide metadata for your Parquet files as well. So how do we get started with Delta Lake? In the Python world, it's as simple as pip install, or with Cargo, similarly. In Horizon, we've provided managed Apache Spark environments with both Synapse Analytics and Databricks. And so I'll show some examples with those. Writing to the Delta Lake. So in this simple example, we've created a data frame, which is a simple table, one column called X with a value of 1, 2, and 3. And we write that data frame to a local folder called My Delta Table. If we look in My Delta Table, we see then that it's written in a Parquet file, and the Delta log folder, which contains the metadata, containing all the transactions about the table, and all the Parquet files that represent each version of the table. So how do we write this to HDL in Azure? Well, then we just need to change this to a Azure Blob File System URL, a change URL. Here you specify the container and the storage account where you want to write to. All of this you can find when you set up a team with Horizon. I'll come back to creating a team a bit later. So simply changing the location, and you can write to Azure, right? No, I forgot to specify my credentials. It's been a long time since I've been asked for my ID, so I don't often think about it. But how do you specify credentials? There's 3 easy ways in Azure. I'll go quickly through these examples, but because they're all in the Horizon documentation. The first one there, forward, back, there. Using client ID and client secrets, applications you can register through the StartNet identity self-service platform. So you create an application, and then that team will send you an ID and a secret that you can use for your application in production. Or locally, you can use the Azure CLI to generate a token, or just use the CLI directly to get the credentials that you need to run your application locally. So going back to the simple write example again, if we just add the storage options and send those as a parameter to the write Delta Lake command, we can see we will then write the data to Azure. With Spark, it's even easier. In this example, we just read a raw Parquet file, or a Parquet file from our raw storage account, and then specify the new format delta, and save it to a processed location. No authentication details needed. We configure all of our Spark environments with pass-through authentication. So the ID of the user will be sent through to the storage account. So you don't need to think about that. That's a simple creating a table, but so a delta table has this concept of modes. The default mode is what they call error mode, where you create the table once, but then if you try to write the data frame to the same delta table, it'll throw an error saying you've already created the table. So a more common use case is to specify append mode, and in this case then you would append the data onto the end of the table always. There's no primary keys or anything out of the box, so it'll always just append whatever the data frame is that you send in. In this example here, we've appended 4, 5, 6, 7, 8 to 1, 2, 3. But perhaps a more useful or exciting use case then would be the merge syntax, where you can then specify a predicate to identify a type of primary key for your data, and then you can also specify what you want to happen in the case of the merge. In this case here, I've said when not matched, insert all, so any rows that don't match the predicate I've specified there will be inserted, and the rest will be ignored. So in this case, 9 and 10 would be inserted, but number 8 would be ignored. The syntax in Spark is very similar, so Python and Spark APIs keep their syntax intentionally very similar to keep the learning threshold low. Another table mode then is overwrite mode. So let's say we just wanted to drop the whole table and create or not drop it, but replace all the contents of the table with something completely different. This might be useful if the data changes rapidly every day. So then by specifying mode overwrite, all the data is replaced with just the rows that you sent into the latest data frame. What does this look like in our folder? Well, if we looked here in this is my local folder again, I've got loads of Parquet files, and in the Delta log file, there's a list of transactions. Every example that I've gone through here in this demo is recorded in that Delta log, and that means that there are 4 versions in the history table, and this provides what's so-called time travel in the Delta Lake format. I can then use this in the Delta Lake API to go back to a particular version if I know the version number, or if I want a particular date, how the table was at a particular date, I can also use the time to go back. Partitioning, also if I get lots of having all the Parquet files in a single folder like that would eventually not be very efficient. So one mechanism for managing that is what they call logical partitioning. And with this, I can choose a column from my data frame and use that as the partition column. So normally you would choose a column that has fairly low cardinality. So that would say not many unique values in your data set. So a traditional example is if you have a date or just a year, you would use that. And you can have multiple values as well. So you can go year and then month and then date within each of those folders, just to make sure that each folder contains a limited number of data, which in turn makes it a lot faster to query when you're trying to, if the usage of your data is to get the data out again based on time, then partitioning by date like this is a very effective technique. Speaking of querying then, how do we query with the API? The first example there shows how to do it with the Delta Lake API. It's not the most intuitive, but it's a way of reducing the amount of data that you return from the engine. Similarly with Spark, you can, there's 2 different examples there with Spark, one using the PySpark API, or alternatively using Spark SQL. In Spark SQL, if you're more familiar with SQL than Python, then it's great for working with that data. And you're processing this directly against the Delta table. Again, there's no server in the middle, or no SQL server, should I say, to get your data. Delta Lake features, there's loads more features, and not enough time to go into all of them really in much detail. But I've talked a little bit about transactions and metadata, schema enforcement and evolution as well, so you can make sure that schemas don't change as they send in new data frames every day, or you can allow that if your use case expects the data to change, new columns to be added or removed. Constraints as well. To a Delta table, you can specify a constraint like a not null value, or you can also encapsulate more complex logic than that. For example, if you wanted the value to be greater than a certain value, a certain number. Change data feeds as well. That's a way for tracking the changes to your Delta tables. So you basically create a separate table that will record all the changes, inserts, updates, and deletes to your tables over time, which might be useful for your use case. And deletion vectors and other optimizations. These for improving the performance of your queries. Auto-compaction will reduce the number of files. So instead of lots of small files, you can combine them back into one big Parquet file, for example. Data skipping, Z ordering, V order, liquid clustering, they're all methods for making sure that your data is located as close to related records as possible to improve the performance, the query performance. Right, so that is Delta Lake. Let's go quickly on to Spark then. I now have 5 minutes. So Spark, the Spark managed compute that Horizon can provide out of the box, we provide both Synapse Analytics and Databricks. The benefits of Spark and these environments is that you get third-party libraries, widgets and visualizations out of the box, and first-class Delta support for all the features that I mentioned just now. Spark has a few different APIs you can use. So PySpark is probably the most popular, but there's also Spark R language, Spark SQL specifically, and Scala Spark. Also, Synapse features good integration, or out-of-the-box integration with Synapse and ML, which in turn is very useful for a lot of machine learning, data science use cases. Similarly, Databricks, not to be outdone, they went and spent $1.3 billion buying Mosaic to integrate into their data platform. So Mosaic provides, again, more ML features and geospatial tools and techniques, very useful. We are still working with getting a lot of this approved, so specifically regarding OpenAI and so on. We have to go through an approval process at .NET to get them enabled, but we are working on that, and it's just a question of time. Spark Connect also is a great feature of Spark. With this, we can separate the code from the Spark cluster. This came recently in Spark 3.4, where, the separation from the client and the server means that you can then run the client in your own compute. So, for example, in STAS, the StartNet OpenShift cluster, we can program a Spark application in a variety of client languages, Go, R, Rust, Python, so on, and then execute the computation of the data in the remote cluster, so for example in Databricks, and which would then fetch the data from HDL in the cloud. So the application can be run on-prem, but the data and the computation of the data remains in the cloud, and then only the result would be returned back to the on-prem computation. And so a quick bonus feature after Spark then is SQL Serverless, a way to consume the data. So both Synapse and Databricks provide a SQL Serverless option, but with our current network configuration, it's been easiest to set this up with Synapse. Each Synapse workspace provides a serverless endpoint, and using this, you can connect it using any JDBC or ODBC client, dbeaver, Azure Data Explorer, Power BI. Again, keeping with Entra ID authentication, so it's within the security constraints of StartNet. And so with this endpoint, then, each data team can go in and create a view of their data. So they would define the view as they want their data to be presented, and then the clients that connect to the serverless endpoint will use the SQL select star from my delta in this example to extract the data that they want. So one feature we're doing right now is to connect this to Grafana, the on-prem monitoring environment, allowing teams to have an overview of their data within the Grafana infrastructure. Right, so that was this talk in one slide, 45 slides later. Horizon, Delta Lake, and Spark. If you have any questions, then go to the software engineering pages at StartNet and look for Horizon. We also have a repository on GitLab, which we will try and document all of these examples and more. More coming. And there's also a new book coming out. I'm not the author, but it's still a good book. To explain more about Delta Lake and the features that are coming and that exist. So thank you very much.